Hello, everybody. Welcome to week 3 of Math 245. Hope you had a wonderful weekend. Hope you got to enjoy some sun outside or doing something fun. So this is week 3 of Math 245. We are done with matrices for now. And now we are going to move on to how to solve linear inequalities. We've looked at linear systems of equations in the first week and a little bit with matrices as well. Now we are focusing on inequalities, and today we are, in this lesson, talking about how to solve linear inequalities using a graph. So first of all, a linear inequality in two variables can be represented by a function that looks like y is less than or equal to, or less than, greater than, or greater than or equal to mx plus b. So this mx plus b is just a linear equation as we know them. But instead of y equals mx plus b, we have an inequality. A linear equation graphically is the line we get when I graph y equals mx plus b, and then we represent greater than or equal to and less than or equal to with a solid line, and greater than and less than with a dashed line. So we'll be sure to do some examples. So how do we solve a linear inequality by graphing? Well, I first graph mx plus b, then I decide if it will be a solid line or a dotted line, and then I can test a point in either one of my regions, and I can plug it into my equation to see if it is true. So let's do this example. Y plus 3 is less than or equal to 2x. Well, first of all, it's not in the form y equals y equals mx plus b, so I need to get it into the form y equals mx plus b. So right now I have y plus 3 is less than or equal to 2x. And to get it into y is equal to mx plus b, I need to subtract 3 from both sides. So I get y is less than or equal to 2x minus 3. So my first step is just to graph this thing. And I know how to do that. So my y-intercept is negative 3. That gives me this point right here. And my slope is 2. So I go over 1 up 2, over 1 up 2, over 1 up 2. So this is my line. And I know that it needs to be a solid line because I have greater than or equal to. So why does it change from a dotted line to a solid line if I go from, say, less than to less than or equal to? Well, this equals means that the points that are on my line are included in my set of solutions. If I had something like less than, that would mean that the solutions or the points on my line would not be included in my solution set. And so that is why I represent something like less than or greater than with a dotted line instead of a solid line, because the points on the line itself are not part of the solution set. So this is the line, but now I need to decide if I need to shade this region here or this region here. Which side of my line makes this inequality true? Well, I can pick any point on either side of the line, plug it into my original function, y plus 3 is less than or equal to 2x, to see if it is true. So let's pick an easy point, 0, 0. So I'm going to test the point 0, 0. So I'm going to plug 0, 0 into our original equation right here. So I get y plus 3 less than or equal to 2x. So I get 0 plus 3 less than or equal to 2 times 0. So 3 is less than or equal to 0. Well, obviously this is not true. So since this point on this side of the line is not in my inequality, I know that the shaded region should be this part. This means that any point on this side of the line, and in fact including this line since it is solid, is a solution of this inequality. So any solution over in this red shaded region makes our original inequality true. All right. Moving on to the second example. Which of these screenshots from Desmos is the graph of the linear inequality y is less than negative 2x minus 2? Well, first of all, I see that I have a less than, which means that my line, the points on my line, is not going to be included in my set of points. So this means that I should have a dotted line, since the points on the graph, the points on the line do not make this inequality true. So C is a solid line, so that one's out. Now I just need to see what my graph of negative 2x minus 2 looks like. Well, I have a y-intercept of negative 2. And it looks like, let's see, these are each going down by 2, 2, 4, 6, 8, negative 10. So all of these, A, B, and D, do have the right y-intercept. And then I have a slope of negative 2. So I'm going to go to the left one and up 2. It looks like A is going up 1 over 2. So this has a slope of negative 1/2. So A is out. So now we're between B and D. It looks like these are actually the same line, but with the opposite regions shaded. So we need to pick a point, test it, and see if it is in our set of solutions. The easiest one is 0, 0. So let's test 0, 0. So that gives me 0 is less than 0 minus 2. Or 0 is less than negative 2. That's not true. So we know that the point 0, 0 should not be included in my shaded region. This tells me that B is the correct graph. All right, that is it for this lesson. Pop on to lesson number 12, and I'll see you there.